so first thing, 14 through 21, you're going to be finding vector AB. And the key thing to remember on that one, it is always the second subtract the first one. Whichever is the second letter is the one you think of first, and you subtract the first value from it. To find magnitude, magnitude is just your distance formula, which some of you recognize that. X minus x squared plus y minus y squared. 23 through 31, you're going to be performing operations, addition, subtraction, multiplication. And 36 through 41, you're going to write it as the sum of unit vectors, which is going to seem kind of easy, because all you got to do is put a plus sign and put an I and a J.
And then magnitude.
Magnitude, which is, you're just going to square them and put them underneath the radical. Okay, so first example, 14 through 21. My ordered pairs are 3 and 2, and B is a negative 1 and 7, and I want to find vector AB. So to find vector B, you take B subtract A. So what's a negative 1 subtract 3? What's 7 subtract 2?
5.
There's your first answer. Now magnitude. How do I find magnitude? X minus x.
Isn't that just negative 4 squared?
We're going to talk about that in a second. Hold off there, Delaney. And y minus y. So I get 4 squared plus a negative 5 squared. So square root of 41. Does everybody follow that one through? And then Delaney was saying, isn't it just these two numbers squared? And that's what I kind of use at the end to check it. If I square this and square this, does it end up being that? So that way you have a check for it without me having to check it. Tomorrow we're going to be doing the same thing, except it's going to be three-dimensional. So we're going to have three-dimensional ordered pairs. We're also going to graph in 3 dimensions. At least one problem. Okay, so we're going to start by finding vector AB. Okay, so Taylor, we'll start with you. What's 7? Remember, it's the second one, subtract the first one. So it's 7 subtract a negative 5.
7 plus 5. 13. No, 12.
12. Okay, JC, what's the Y? Negative 9 subtract a negative 2.
Negative 1.
Okay, let me write that down. Negative 9 subtract a negative 2. Two negatives make a
Oh, yeah. Negative 7.
negative 7. Magnitude. Richard, what are my x's?
Negative 5 and 7.
So negative 5 subtract 7. What are my y's?
Negative 2 and negative 9.
So I'm going to end up with negative 12 squared plus 7 squared.
144 plus 49.
Now, if your radicals can be simplified, I do expect you to simplify. 193. Everybody concur? And I don't think anything goes into that. Now, could you check it?
Yeah.
What's this number squared plus that number squared? Do I get the same thing?
Yeah.
Does everybody agree? Another one, or are you satisfied with that?
We're satisfied.
Does anybody want another one?
Some plus
Not for that.
Not for that. I don't think any of them are going to need that many. 23 through 31. You're going to have, and I don't know what variables they use in the book, but I'm making up my own. Let's do an easy one. You're going to find vector u, which they ask you to find, they call it vector a. Mine's vector u. Okay, but it doesn't matter what variables you use in the problems. Everybody follow me there? I just use different things up here. So what's it tell me to do to find u? Add a and b together. So all you got to do is add those numbers together. So what's a negative 2 and 5?
What's C?
C is 15 and 4. So what's a negative 2 plus 5? And what's 1 plus a negative 6?
Negative 5.
There's your answer.
Oh, okay, that's what.
Now let's make this one a little bit more work. So what will I do on this one to find out what vector u is?
You multiply 3.
Multiply everything in a times 3. So let's see, Becky, everything in a times 3 is going to be what?
-6. And then 3.
Okay. Now here you got a choice on b. You could either take everything in b times a -4 and add, or you can take b times 4 and subtract. So Tara, which would you rather do? Would you rather add or subtract?
Add.
So we're going to add, so that means you're going to multiply everything in b times a -4. So what will you get?
-20 and 24.
And now what does those add up to be?
-26 and 27.
There's our answer.
Can we do another one of those?
We're did more.
Where did the -4 come from?
That was just the problem. That's what I made up as the problem. Let's go 2c plus 4b minus vector a. Okay, so we're ready.
Please release the high school track team for their meet today. Good luck, everybody.
Okay, Dalton, you get to take everything in c times 2.
30 and 8.
Okay, and Mason, everything in b gets multiplied by 4. There's b, and you gotta take everything in it times 4.
So 20.
20.
Yeah. -24.
You just multiply both the x and the y by the number that's in front. It's just
Okay.
distributive property, basically.
Okay.
And now we're subtracting a, so Delaney, you got a choice. You can either add or you can subtract. Which would you rather do? Delaney, yes.
Oh. Add.
So that means you need to multiply everything in a times a -1, right?
Yeah.
Okay, so if you multiply a times a -1, what will you get?
2.
And now Delaney D, you get to do the adding.
Okay.
So you got 30, 20, and 2 are all the x's.
Okay, so it's going to be 52.
And then you got 8, -24, -1.
-17.
Everybody agreeable? Okay, let's do another one. This time, let's go 2b minus 5a. So we're ready for Zach. He gets to take everything in b times 2.
10 and -12.
And Taylor, everything in a, you rather subtract or add?
Add.
So you want to multiply a times a -5.
So 10 and -5.
And then JC, you get to add them together. So adding the x's, you get
20
mhm,
and -17.
right. Does everybody follow what we're doing in that group? Does anybody need more examples? Now, remember that they're using different letters than I'm using, different variables, but it's the same process. You're adding or you're subtracting or you're multiplying. The last group is 36 through 41. And this you're rewriting as a sum of unit vectors. They're giving you a vector. They use this. I still use ordered pairs, so just so you know it. So I'll be writing it this way. To write this as a sum of unit vectors, and the ones we want to get used to using is I, J, K. When we go three-dimensional, we'll add the K. So I, J, and there's a reason for that. When we start doing cross products, we have I and J involved. So this would be 5I minus 6J. That's the first answer. That's all you do is you put it with I's and J's. I told you it's going to be fairly simple. Now, the next thing is to find the magnitude. The magnitude is just where you square each of these and put it under the radical, because there's nothing to subtract, it's already a vector. So it's going to be the square root of 5 squared plus a -6 squared,
So square root of 25 plus 36.
51? And that would be your magnitude. Okay, what if I have 8 and 4? So what would be the sum of the unit vectors? 8 I plus 4j. Now its magnitude, 80, but that we can simplify, can't we?
8 and 10.
What about 16 and 5?
16 and 5.
Four
So
squared
4
is
squared is 5.
Let's throw in a negative number. What about a negative 2 and 0? Plus 0j,
Yeah.
and its magnitude. And I think somebody missed something on the test. They had a negative 2 squared and, oh, I remember where it was. I'll come back to that. That ends up being square roots of 4, which is 2. And they probably were doing it on their calculators, but it was a negative 2 squared. This was on the test. I had somebody tell me that was 0. But isn't it a negative 2 squared a positive 4?
Yeah.
Plus 4 would be 8. And if you put it in your calculators, I know there are some calculators that require parentheses around it. So if you're one of those calculators, it can catch you up later on. Unless you remember that if you have 2 negatives, your answer is a positive. Okay, let's do one more. Let's go with a negative 5 and a negative 6. So what would be it written as the sum of unit vectors?
Negative 5I minus 6j.
And then the magnitude would be a negative 5 squared plus negative 6 squared. Is everybody agreeable? Okay, do you guys have questions?
No.
Okay, so again, 14 through 21, you're finding vector AB. Remember, that's B subtract A, and then you find its magnitude. You really have a check for that one if you want to use it. 23 through 31, you're performing the operations. I think they call it vector A is what you're coming up with. And then 36 through 41, you're writing it as the sum of unit vectors using I and J, and then also finding its magnitude. Do you guys have questions? Anybody questions? Okay, then I'd like to see everybody's first 4 problems.